Hello, Cardinals. We're going to be doing investigation 3.2 today. We're going to be looking how water can change over a 24-hour period. Our topic today is modeling the water cycle. But before we do this investigation, we're going to look back at investigation 3.1, which was yesterday when we discussed evaporation and condensation. And a little review from that. Here's a example table that you could have made. Your teacher will probably discuss this as a class, but here you have your two examples, water, hot water in the bottom of the 2-liter bottle, and cold water. Hopefully you took the temperature of each before you put it in. Observations of a plain bottle. You should have observed it before you started. And then what happened when you put ice on the bottle and your warm hands. So, we talked about this yesterday. If you're not sure, there is a investigation 3.1 video. But basically, the hot should have condensated right away. Cold did not. But then as you put ice on it, both hot and cold should have condensed more. And then your warm hands could have gotten rid of the condensation. So temperature plays a role in both evaporation and condensation. We're going to take a minute and you're going to write and describe how water condenses and evaporates and how these processes play a part in cloud formation. So you should do number 1 and answer that question in your notebook. How does the temperature affect condensation and evaporation? And then we're moving on to investigation 3.2. And during investigation 3.2, we're going to look at the water cycle and how water changes over 24 hours. And we're going to determine the basic conditions in which water moves through air. So you're going to be observing how water under a light is going to change over 24 hours. So for this lab, it's kind of a recipe lab. It's going to tell you exactly what to do. You're going to begin by putting lights out, which your teacher will probably have out for you. You're going to put 20 milliliters of blue water into a little measuring cup and take that mass and record it in the table on student sheet 3.2. And then you'll fill a cup with ice and find the mass of that. So you're starting out with a couple different masses of ice and water within the cup. And then you're going to need to add the mass of the measuring cup with the water to the mass of the measuring cup with the ice and record that total mass. So you're going to be figuring out exactly how much you have. Your teacher may also have you put the entire system together and measure that, but it depends on the teacher. You're going to place all of that into a larger plastic container, kind of a little Tupperware container, and then you're going to place that lid down firmly to secure it. That creates a closed system. And then you're going to make some observations of the container and think about all the different places in the container where the water might be. So you got to think about where the water might be during this. You have the cups, you have water, ice, and you actually have water vapor within the air. And that should go on student sheet 3.2. And then we're going to put that underneath the light source to simulate, light and what happens after exposure to light for 24 hours. So investigation 3.2, modeling the water cycle. There's 10 steps to that. That's in your textbook on page 28. This is a 2-day lab. We'll investigate what happens tomorrow, day 2. When you get done, you're going to want to read through part 2 of investigation 3.2 and then read building your knowledge, the water cycle from the sky to the land and back again. Your teacher may have also showed a video in class called the water cycle. It's called a twig video. They may or may not post that on Google Classroom, but if they're not, you can definitely ask them. So good luck today, Cardinals. Let your teacher know if you have any questions.